How does FM synthesis use math to make sounds? Imagine creating a sound not just by pressing a key but by shaping it with numbers and equations. That's what FM synthesis does, using math to craft complex, unique sounds. At its core, FM synthesis relies on oscillators, which are simple mathematical functions that generate waveforms like sine waves. Think of a sine wave as a smooth, repetitive curve that rises and falls evenly. The main oscillator, called the carrier, produces a basic tone at a specific frequency. The second oscillator, called the modulator, changes this tone over time. The magic happens when the modulator's wave affects the carrier's frequency. It's like adding tiny, precise shifts to the pitch of the sound. The amount of this shift is called the modulation depth, and the ratio between the modulator's frequency and the carrier's frequency determines how the sound evolves. Mathematically, the output of FM synthesis can be written as a sine function where the phase of the carrier is altered by the modulator. This means the carrier's phase is continuously adjusted based on the modulator's wave. When you do this, you create new frequencies called sidebands around the original pitch. These sidebands are like musical siblings, each with its own tiny difference in pitch. To understand how loud each of these sidebands is, sound designers use a special mathematical tool called the Bessel function. It helps predict how energy is spread across these new frequencies. The key parameter, called the modulation index, is the ratio of the modulation amplitude to the modulator's frequency. Changing this ratio shifts the balance of the sound's harmonic content, making it brighter, more metallic, or more bell-like. In digital synthesizers, FM synthesis is efficient because it only needs sine wave calculations and simple math. This makes it quick to produce a wide array of sounds without heavy processing. By adjusting the modulation index, frequency ratios, and how the oscillators are connected, sound creators can craft everything from smooth pads to sharp, percussive tones. So, in essence, FM synthesis uses sine functions and Bessel functions to mathematically manipulate frequencies. This allows sound designers to shape complex, evolving sounds with precise control, all through the power of math.